Hello, I am Mr. Murphy, and today in this video we're going to be looking at power standard number 15. In this particular power standard we're looking at finding the maximum and or minimum values of a function. Now I know this is part of chapter 6, which is dealing with quadratics, but this power standard could apply to more than just parabolas. It could apply to other polynomials as well, which we will get to later on in the year. So this video you might be looking at now, currently in chapter 6, or maybe in a future chapter. But just know that these rules, or these things that we're going to talk about, apply for any number of different situations. So since we're right now talking about quadratics, we know that a parabola can open upwards or downwards. We know that if a parabola open upwards, then that particular parabola has a vertex with a minimum value. Or if a parabola opens downwards, that vertex is going to represent the maximum value. Like I said, that idea, that concept can apply to more than just parabolas. Let's look at some examples here. Wow, that's a lot of stuff. You want to make sure you get your notes and you take good notes here. So let's start by looking over there at the absolute maximum. Absolute maximum, you can see from the graph there, is, well, the textbook definition is it's a value of a given function that is greater than or equal to any other value of the given function. And in other words, an absolute value function is the greatest of all the values. And we're looking at the, in this case here, there would just be just the one absolute value, or absolute maximum. If we had two that were at the same height, then we could have a situation that would have two absolute maximums. Or on the flip side, we could look over here at the next box, and we could see that we could have an absolute minimum. The textbook definition of that is that it's a value of a given function that is less than or equal to any other value of the given function. An absolute minimum is going to be the lowest of all the values. Makes sense. It's the absolute minimum. In the previous one, it's the absolute maximum. Well, there are two other situations. We could have a relative maximum. This would be a situation where you could have more than one relative maximum with different values. A relative maximum is just going to be a value of a function that is greater than those of the function at the surrounding points, but is not necessarily the greatest of all the values. So for example, this here would represent a relative maximum, because in that interval there, that is the maximum value in that interval. Or over here we could have another relative maximum, because in that interval that represents the relative maximum in that interval. So that you could have relative maximums that are two different numbers, but an absolute maximum, there would just be a single one, unless there's two with the same maximum height there. Same thing is true for a relative minimum. Pretty much the same idea as the relative maximum, only we're looking at minimum values here. A relative minimum is a value of a function that is less than those values of the function at their surrounding points, but it is not the lowest of all the values. Again, here you could have a couple of them, like in this interval, there's that relative minimum, and in this interval here, there's another relative minimum. So this graph here would have two relative minimums, just like the previous one had two relative maximums. Let's be more specific here. Let's look at a real example here that you might see. It says, based on the graph above, what coordinates on the graph are relative maximum? Well, we actually have two of them here. So there's two coordinates. The first coordinate that would have a relative maximum would be the coordinate -4, +2. And the other one would be the coordinate -1, +1. Now the maximum values of those would just be the 2 or the 1. But since they're asking for coordinates here, we would say it's -4, 2, and -1, 1 would represent the relative maximum there. When they say what coordinates on the graph are relative minimum, again, we have two of them in this situation, so we would have the coordinates here would be -1, -2, and we'd have the coordinate +3 and a -1. Now the next part, it says, what coordinate on the graph is an absolute maximum? Well, we're looking for the absolute maximum here, so in that case, this is the highest one. So that would be the -4, +2. Then it says, well, what coordinate on the graph is an absolute minimum? Well, the absolute minimum here would be the lowest point on this graph. And the lowest point here is the coordinate -1, -2. Relatively easy concept. Why don't you see if you can do this one on your own? So pause the video and hit play if you're ready to check your answer. Okay, so the first one, what coordinates on the graph are relative maximum? We only have one, coordinate 0, 1. What coordinates on the graph are relative minimum? Well, we have two of them there at -1.22 and -1.25. And the other coordinate where it's a +1.22 and a -1.25. What coordinate on the graph is an absolute maximum? Well, we only had one maximum, and the absolute maximum would be the coordinate 0, 1. And what coordinate on the graph is an absolute minimum? Well, that would be both of these, -1.22, -1.25, and a +1.22 and a -1.25. So at those two coordinates, you'd have the same absolute minimum, where we would only have one absolute maximum. So there you have it. There's your power standard number 15. Hopefully that made sense to you. Seems to make sense as far as the idea of having an absolute maximum and an absolute minimum would be the absolute highest or lowest points. Hopefully relatively simple concept. And with that, good luck on those future power standards.